Ramanujan for G is now available on the Google Play Store. Try it out for free.
Yeah, good morning, students. So, in the unit permutations and the combination, we'll start with the topic counting formulas for combination. Okay. For the combination. Okay. So, in this, first we'll start with the selection of objects. Just a minute. Okay. Yeah, the selection of object without repetition. Okay. So, in this, first, like the number of combination of n different things taken r at a time is denoted by NCR, NCR, or we can write C of NR, or again we can write n by r. So then becomes NCR is n factorial by r factorial n minus r factorial. That is 0 less than equals to r less than equals to n. So it becomes NPR divided by r factorial, that is n of n minus 1, n minus 2 goes up to n minus r plus 1, and whole thing divided by r of r minus 1, r minus 2 goes into 2 into 1. Okay, so we can write if r is greater than n, then NCR is equals to 0. Okay, so we can make a note for this. So now important results. Okay, first is NCN is equals to 1, or we can write NC naught is equals to 1. Second, NCR is equals to n PR by R factorial. Third thing, NCR is equals to n of C n minus R. Fourth, NCX is equals to NCY, that is x plus y is equals to n. Next is NCR plus n of CR minus 1, that is n plus 1 CR. Again, next thing, NCR is n by R into n minus 1 C of R minus 1. Next is NCR is equals to 1 by R n minus R plus 1 and n of C R minus 1. Next is NC1 is n of C n minus 1 is equals to n. Okay, so these are the 8 formulas you need to remember. Okay, so you can copy it. Okay, so next thing, if 20 CR is equals to 20 CR minus 10, then 18 CR is equals to what? Okay, so let's solve. 20 CR is equals to 20 CR minus 10, that is R plus R minus 10 is equals to 20. So here R is equals to 15, right? So next 18 CR is equals to 18 C 15. 18 C 15, that is 18 C3. So that is 18, 17, 16, and 1, 2, 3, that is 816. Next, example 15th of this chapter. Okay, so how many combination of can be made of the letters of word Jaipur? Okay, so that means here 4 things are to be selected out of 6 different things. So the number of combination is 6C4, that is 6 into 5 into 4 into 3, and 4 into 3 into 2 into 1, that is 15. Okay, next is selection of objects with repetition. So the total number of selections are things from n different things with when each thing may be repeated any number of times will become n plus r minus 1 cr. Let's look out at one example. 8 pens are to be selected from pens of three colors, pen of each color being available any number of times. Okay, so then total number of selection is, so that means 3 plus 8 minus 1 C8, that is 10 C8. So we can write 10 into 9 into 2. So that would be 5 and is equals to 45. Okay, next is restricted selection or arrangement. So that means the number of combination of n different things taken are at a time. So that is when k particular objects occurs is n minus k c of r minus k. So if k particular objects never occur is n minus k c of r, right? So the number of arrangements of n distinct objects taken at a time so that the k particular objects can be selected, which will include n minus k c r minus k r factorial for always included. For never included, it will be n minus k. Here also it's n minus k c of r factorial. Next is the number of combination of n objects of which p are identical, taken r at a time. Okay, so that will be n minus p c of r, n minus p c of r minus 1 plus n minus p c of r minus 2 and goes up to n minus p c naught if r is less than p. And similarly, n minus p c of r, n minus p c of r minus 1 plus n minus p c of r minus 2 and goes up to n minus p c of r minus p if r is greater than p. Next is question from four gentlemen. Wait, from four gentlemen and six ladies. A committee of five is to be selected. Okay, so the number of ways in which the committee can be formed, that gentlemen are in majority is. Okay, so the committee will consist of four gentlemen and one lady, or three gentlemen, two ladies. Okay, right? So that means 4c4 into 6c1 plus 4c3 into 6c2. So solving, will get this as 66. Okay, next is selection from distinct object, meaning the number of ways of n different things selecting at least one of them. So this will become nc1 plus nc2 plus nc3 goes up to ncn. So that is 2 to the power n minus 1. This can also be state as the total number of combination of n different things. Now let's look at one example. Like Ramesh has 6 friends. In how many ways can he invite one or more of them at a dinner? Okay, so meaning he can invite 161, he can invite 262, he can invite 64, invite 65, he can invite 66, or he can invite 63 also. So that means 2 to the power 6 minus 1, that is 64 minus 1, 63. Okay, so with this, we are going to wind up this session here. We'll take more examples in the next class.